Hi, everyone. How are we doing? Good? Yeah? Let's get a little energy going. Yeah. We do have coffee after this, so just survive me and it'll be good. I'm super excited to be here at my first ever KXCon. I have to appreciate that usually going to finance conferences, you all wear sneakers. That's awesome. I love it. My talk today is on accelerating machine learning with the use of KX. I have to hit the big green button. Okay, cool. So picture this. You sit down at your computer, ready to delve into the exciting world of machine learning. You've spent the last month or so pulling your data, formatting your data, and cleaning your data, and now you're ready for the fun stuff, right? The feature engineering or deciding what inputs to pass into your model, model selection, so deciding between random forests, neural nets, or something else, or model optimization, deciding how many layers your neural net has. You stretch out and you crack your knuckles, ready for some solid, intellectually stimulating work. You open up your programming environment, which for us at Virtu is a shared Jupyter Hub. And I do need to emphasize, I am not a developer. So for all of you developers in the room, thank you for all the work you do. This is what makes my job possible. So I open up my shared Jupyter Hub, and I type in df.head to Python to preview my data. I spend a few minutes splitting my data into a testing and training data set, and I run it through a simple random forest model, excited for that first cut of performance. Crap, 5%. What the heck am I supposed to do? I didn't think that I would have 100% that first time through, but I thought it would be better than 5%. I frantically scroll back up in my code, and I realized I left out a critical feature. It is going to take me days to repo my data, let alone all the formatting and data normalization that I already had to do. My name is Erin Stanton, and I run the Global Analytics Coverage Team at Virtu Financial, and I cannot count the number of times that I've been stuck in this situation where I've spent hours, days, weeks to realize I left something out, and I'm sure, can some of you relate to that? Anyone had that experience yet? I'm seeing some heads nodding there, which is great. Thankfully, for my sanity, Virtu embarked on a complete rebuild of our entire firm-wide analytics infrastructure 5 years ago, choosing to move everything in KDB. Clearly, that's why we're here. This decision completely transformed the way that my team works and allows us to really focus on what matters for us, which is delivering value to my end customers, which is the buy side and sell side brokers. Today, I'm excited to walk you through the architecture that we've built in KDB, which completely changes my day-to-day, allows my team to focus on, when it comes to machine learning, the value add of feature engineering and model selection, and not worrying about data pulling. And I'm even going to walk you through a model that we're actively researching. I did get this signed off by compliance. A model that we're actively researching so that you can see this all happen live. So before diving into the technical details, I know a lot of you are in the same space, right? But let's talk about the analysis that my team does, because we're a little weird. We are a transaction cost provider, so we sit amongst the buy side and the sell side at Virtu. So I realize some of you in the audience may be familiar with transaction cost analysis or trading analytics, but let's make sure we're on the same page. My team at Virtu Analytics provides services and consulting to large asset managers and sell-side brokers, helping them to understand how to trade more efficiently. So very simply put, is anyone from BlackRock here? No? Okay, because I used you as an example. So say you have a large asset manager like a BlackRock. They decide to buy a stock like Apple. They're going to be trading millions and millions of shares. You can't just go, right? We all know this. You can't just go. It's not like you're, e-broker, and you can't just go and find a price on the screen and trade all of those shares. You're buying 100 shares here, you're buying 100 shares there, and this takes time. What happens in the stock market as time moves on? The price changes, right? So my team is helping these clients, like a BlackRock, decide how to trade most effectively to get the best price for their end consumer. We look for the optimal ways to trade and give them advice on this. Because clients, again, like a BlackRock, are using my models directly to make decisions on their trading strategies. It's really important that the models I built, and yes, we do also build price impact models, that the models we build are accurate, efficient, and most importantly, adaptable. So the legacy Virtu analytics infrastructure was built prior to me joining the firm in 2008. I did just celebrate my 15-year anniversary last week. So you can only imagine the type of technology that was available back then, right? I know I had a BlackBerry. I'm pretty sure I was trying to figure this out. I'm pretty sure I was still using an iPod, and I absolutely know that I was using that Netflix DVD mail-in service, right? So all of our transaction data was stored down in Sybase IQ. Our market data was in a completely separate architecture. And our reference data or mappings was just stored, all over the place. Every group had their own reference data. They didn't match. It was just a complete mess. So don't get me wrong, right? I'm not here to disparage SQL, and it sounds like KX is going to have some sort of SQL interface, which is great for all those SQL lovers. But from my perspective, it made sense for us to move this all into Python. So let's walk through the KDB-based architecture that we've built. I'm sure a lot of you are going to be like, yeah, we all have the same thing. But for me as a data scientist, this was like Christmas morning when this showed up and I got to use it. So we have one database for trade data, we have one database for market data, and we have a firm-wide reference database. So no one has their own reference data. It's all combined now. So when trades are ingested into our trade data, it's enriched with market data like everyone's already doing. We calculate spread metrics, price metrics, all of that good stuff. The real game changer, though, is the API infrastructure that was built on top of KDB. So as an end user, I cannot write a lick of Q. I wouldn't even know where to start. I don't have to worry about that. I just use the APIs that we've built at Virtu to call market data, to call trade data. And when I say I'm calling market data, I'm not calling raw ticks and raw quotes. I don't want to deal with that. I want condition code filtering already built in. I want holidays built in. I want corporate actions built in. I don't want to deal with all that stuff that all of you KDB developers have to worry about. I want my data clean and ready to go. So instead of relying now on SQL, I can rely entirely on Python. And I'll give you just an example of how transformative this was for me to move from the old SQL database to Python. So I used to have, and hopefully they're not in the room, so I used to have a client that I would produce a report for out of SQL, and it took 8 hours to run. It did have complex data manipulation and aggregation in it, but a full 8 hours. I moved this over to Python and using our APIs built off of KDB, and it takes me 5 minutes to run now. When that client used to write me in, right, they'd email me and they'd be like, oh, we have a question on this report. It was like, good luck, right? It took me 8 hours to run the report the first time. You now want me to investigate this? It's like, I'll get back to you in a month, I guess. Now it's all same day turnaround. So just a complete transformation for us. Open technology. You're going to see a theme. We do have a lot of stuff that starts with open. Going to get to open until later. So open technology is the name of our internal and external developers toolkit. And this is the API platform that sits on KDB for us. This, as I said, for me as a data scientist, just an absolute game changer. It really is a dream now for me to pull in my data. So it's a little hard, I think, to see here on the screen. You can see kind of a bit with the definitions, and that's actually some sample code. For all 70, yes, 70, all 70 of our API endpoints I get fully documented for me, and this is just as an internal user, also available for external users. I get sample code, all of the request parameters, all of the field names, optional conditions, and I can even try it live. So when I get super lazy and I don't want to even open up my Jupyter hub, I just run my endpoints directly in Open Technology. I know 70 endpoints does sound like a lot, but basically we've built out this entire analytics website. Anything we show on the screen to a user is also accessible as an API. So this includes our fixed income liquidity index. This includes intraday volume curves. This includes any price or interval price that you can imagine across all asset classes. So FX, futures, fixed income equity, all available. We have a block data API. So could I filter block trades out in condition codes? Yes. Can I be lazy at Virtu? Also yes, because I have a standalone API that allows me to pull block trades. All users within our analytics portal get direct access to Open Technology where they can see a list of all 70 of these endpoints. They get a description, and even in here, they can click a little button and request trial access, which comes directly to my team to enable. I've always been inspired by companies like Spotify who make it so easy to try their APIs. And I honestly, for some reason, never thought we would get this within finance. To say I'm spoiled rotten is just, complete understatement. On any given day, I decide there's a market data element I want, a model component I want. It's 5 minutes for me to pull that into a data frame, join that back up with my transaction data. Open Technology has been the clear driver of our ability to do machine learning. Prior to having Open Technology or our APIs, my team spent over a year developing a single machine learning model, a whole year, just one. Since the APIs have launched, we've gone back, rebuilt that original model from scratch, enhancing it along the way, and we've been able to experiment with 10 other use cases. I think I can easily say, have people heard people spend 80% of their time in machine learning on the data, right? We spend less than 50. Pretty good. So to demonstrate this more clearly, I am going to go through a model that we're actively researching. As I said, this is not proprietary. I promise I got this approved. So this model that we're developing is built to suggest the optimal trading strategy for a trader. So my team, as someone who does transaction cost analysis, will often look at the results and say, trade more slowly when you trade small caps, or use a more passive VWAP when spreads are widening, but we actually haven't built a predictive model to suggest what the optimal trading schedule is. So to state more clearly of the goal of this model, what we want to do is take all of our broker neutral trading data, and broker neutral means that, yes, I am part of Virtu, but I'm kind of a little pod over here. So all of my trade data is not Virtu specific. I see the trade data for every single broker on the street. So I take all of that beautiful, beautiful data that I have, and I want to pass it into a model, build a model to help me predict and suggest to an end trader what the optimal trading schedule is. We did try to do this, I want to say, it was after I started, so let's say 2011, it was a while ago. We didn't do a model. We didn't have APIs. It was brutal just to get the data. So all we did was looked in this database and said, well, it looks like VWAP was the cheapest for this stock in these market conditions, so try VWAP again. Was not predictive. So we want to actually build something that has real predictive capabilities. Over the last 6 months, my team has made, I can't even count the number of decision changes on the data. We went from one level of data, we changed it back down to a lower level, we went back up, we brought other data in. Never at any point did data stop our progress in the research. Purely the thing that stopped us was time, where we were like, should we try this? Should we try this? So that's pretty incredible. We're able to assess the performance and metrics that we need to without spending more time than we need to on the data. Yes, okay. So this is actual code that I pulled, not Q, beautiful, beautiful Python. So this is code, sorry. Yay, Q. So I pulled this out of our current research Jupyter notebook. This is pulling 4 months worth of data for all algo trading in the US. To look up basically these conditions that you see here, right? To look up what I needed here, to look up what I needed with the fields, to look up what I needed with the settings. I just went into Open Technology and looked that up really easily. This was our first run. So this is very, very, very basic. The fields that I'm pulling back are the security, the side, the shares I already have, right? Natively calculated my slippage cost. I have some volatility in here. I have some liquidity metrics. So that's all built in for me. Our APIs do, you'll see down there the little batch size, our APIs do have a capped size return. So I do a few batch pulls and I have all my data available for me. So far for this analysis, 5 minutes a time I probably spent. Because I'm already in Python, less good than Q. Because I'm already in Python, I'm able to pass this directly into the native pandas profiling library, which is my team's one-stop shop for EDA. So I start looking at outliers. Let's say that takes about 15 minutes. I decide that I want to pull in the algo strategy field. We have a mapped algo name to algo strategy field. I decide I want to pull that in. So I go down to our reference data, drag in the table I need, and join that back up with this data frame. This type of mapping, by the way, is a perfect example of one that every group at my firm had a different mapping for. So I pull down the unified algo strategy mapping, join that back up, I have my EDA done. I'm now ready to pass it into my random forest model. All in for my first baseline run. Data cleaned, right? Little EDA, nothing really concerning because my data is already pre-scrubbed because I have my APIs sitting on top of KDB. I'm probably at an hour, conservatively. But let's do a little more. So for my first iteration off of that baseline, I want to just take the information that I got from my EDA, add it to my data pool, just to make future runs cleaner. Could I do this in pandas? Yes. Do I want to make my life easier down the road? Also yes. So I decide to filter out high-cost orders, decide this model is not going to be appropriate for microcaps just because we didn't have enough observations, decide to exclude really, really, really large trades. Those are anomaly. And I repull my data, another 5 minutes. At any point in this, right, some of these fields were new here. So to look up what these condition fields were named, I just went back into Open Technology to read how to pull those. One thing I also forgot to say is the amount of data we're working here. And I know you guys are all big data people, so I'm excited by this data, but basically we take in 75,000 orders across all brokers that go through our Triton trading EMS. So 75,000 orders a day is about 6 million orders for this 4-month period. For me, that's not small. I know for many people, that's not big, but this is a decent sized data set for me. I also, one thing just to know, I know the 4-month period is kind of weird. Volatility did change during this time period, so we just wanted a before and after snapshot. Oop. There we go. Okay, so iteration 2, because this is algo trading, we decide that we want to use shorter duration metric. So previously I had, this was actually a 21-day metric. That might be a little long for algo trading. Let's bump that down to 5 days. I did the same thing here for my liquidity metrics. So I swap out those metrics. And I also decided that I wanted to pull in something to account for overnight stock moves. Let's try to start accounting for the market as features into my model. So I added in here a previous close benchmark, an open benchmark, add those all in, repull my data, another 5 minutes. So iteration 1 or baseline, an hour. Iteration 2, all in, pulling my data, passing it through a model, 15 minutes. Iteration 3, pulling this data again, 5 minutes, putting that back through a model. The beautiful thing about REST APIs is when it comes to feature engineering. I decide I want to add in overnight stock movements. No problem. Previous close, open, calculate the difference in pandas, new feature that's ready for my model. I decide I want to do intraday momentum. No problem. Open to arrival, already in my data set, new feature, pass it into my model. The sky is really, I think, the limit when it comes to feature engineering. And I do have a reference point to this, right, because I'm spoiled rotten. I'm teaching machine learning at Virtu. We use Coursera, but we do this kind of weekly call. I just challenged everyone to do the Kaggle Titanic data set, but I was like, don't use random forest, use a neural net, challenge yourself, right? Let's really try this. They came back and said they spent 3 hours formatting the Kaggle data, right? I mean, it's supposed to be good, it's supposed to be clean. The Kaggle data took 3 hours to format. I'm here now on my 3rd iteration at only an hour and a half total in. So I add in those new fields, by the way, and I rerun my model. So for iteration 3, I decided to get a little fancy, and I go out to our market data API, and I decide that there's some metrics that we don't natively save down in our trade data database, but I want to experiment with as a data scientist. I think these might add value to my model. So I pull in things like the quote count, the trade count, all from, in this case, this is my daily data endpoint. I have an interval endpoint that I could have called as well. Add these in, join it up with my data, rerun my model, total time spent, 3 iterations, baseline model, 2 total hours. So in that 2 hours, what I've been able to do is I pulled in data, I did EDA, I ran a model, I iterated once to get rid of outliers, I iterated again to add in more data that would help me with feature engineering, and I iterated a 3rd time to create new features from scratch. As I said, I'm a fan of Spotify, so I have played with their APIs. I thought I was going to create my own song recommendation engine. I can promise I spent more than 2 hours trying to get something super basic off of the ground with their API. Each of the decision points that I demonstrated here, the shorter horizon, the new metrics, these are all decision points that my team is able to add value to the machine learning process, and we don't have to worry about pulling data. There's never a decision that I have to make that's, oh, crud, that data would be great, but it's too slow to pull, or crud, that data would be awesome, but man, that's hard to access. I just don't have to worry about that. We can fully experiment with anything we want. One added benefit of these APIs is we've actually been able to launch a machine learning as a service, that is a mouthful, a machine learning as a service offering called Open Intel, where we now are able to actually provide machine learning to the buy side purely as a service. We were talking to many of our buy side customers, and they all were kind of like, oh, we really want to experiment. We feel like everyone's doing it. Oh no, we're falling behind. Because data is so easy for us to pull, feature engineering is so easy, and then you do the model optimization, we were able to actually give this to them, and it helps them move along in their machine learning journeys. So I can't take credit for any of this architecture that was built. I'm sure, right, many of you in the room, thank you. To my developers in the room, thank you. I'm very grateful for the architecture design that was made, the APIs that were built, because they just have completely supercharged my team's ability to do machine learning. We're actively, on any given day, researching 4 to 6 models. It sounds like, I bet you think I spend 100% of my time on machine learning, right? Based on everything I just said, 20% or less. So without these APIs, I can't even imagine how limited my machine learning research would be with only 20% of my day spent on this type of activity. That's it. Any questions I can help answer? Yes.
That was fantastic. Well, how do you think about the word of GPT?
Candy. Exciting, but so one thing that we have been trying to do in anything we do in machine learning at Virtu is we've really pushed for transparency. So we actually hold monthly, they're called Machine Learning Monday, so they're clearly on a Monday, monthly sessions with our clients where we actually describe what we're doing here. So where I just described this, This is nothing new. My compliance team already knew. I've shared this with our customer base, right? So we try to share everything we're doing, and we push for, the point of that is for transparency, to push our client base to ask questions around what we're doing, right? So when it comes to ChatGPT, I am super excited. We actually want to test out open technology with the ChatGPT plugins. We want to play around with that. But I think probably the most important thing, though, too, is that we all as end consumers of ChatGPT also then challenge back their model, right? So I'm excited by the model, but I also need to hedge that a little with, I hope, we're all pushing for transparency and kind of asking what they're doing along the way. Any other questions? Coffee time?